All right, guys, the title of today's topic is triangle inequalities. Let's look at some of the problems on the do now that was in the Nearpod. It asks you to make a line that is parallel to this one, y equals 1/2 x minus 2. Remember that we're looking at our slopes. This is our slope. When we have parallel lines, our slope is going to be the same. So remember, we are using our y minus y1 equals mx minus x1, the point slope form first, and then getting it down to the slope intercept form so that we can make a line that goes through this point. So our x1 is this 3 and our y1 is this 2. So y minus the negative 2 equals my slope, parallel, I use the same slope, times x minus 3 close my parentheses. All right, whenever I have a negative or a minus a negative, that's really a positive or a plus. So I'm changing that to y plus 2 equals 1/2 x minus 3. Next thing I need to do is I need to take my 1/2 and I need to distribute it to both parts of my x minus 3. That means I'm going to take 1/2 times x. Whenever I multiply a number by a letter, it's just that number and letter. So it will be 1/2 x. And then I multiply my 1/2 times my negative 3. It's negative 3 because that minus sign has to travel with that 3. So we will have a negative number because a positive times a negative is a negative. So we'll have minus 3/2. On this side, we still have y plus 2. Next, I need to continue trying to get y by itself. So I'm going to subtract 2 from both sides. So if I subtract 2 here, subtract 2 here. Remember, when you are moving that number from the left side to the right side, you do not touch your x or anything in front of the x. You're just taking the number minus the number. All right, so on this side, I'm left with y equals 1/2 x minus 3 and 1/2. Or we can change that 3 and 1/2 to 7/2. Those are the same thing. All right, let's look at perpendicular. We're going to follow the same exact method, except for our slope is different, right? For perpendicular, we have the negative reciprocal. So let's look at the first line. My slope here, this line, is really 2/1, positive 2/1. So the slope of my next line is going to be negative, and I'm going to flip my 2/1 and make it 1/2. So let's plug it into our point slope form. Y minus 6 equals 1/2 x minus 4. We follow the same exact manner. We have to distribute our 1/2 first. So 1/2 times x, again, is 1/2 x. 1/2 minus 4 is negative 4/2, which 4 divided by 2 is 2. And we still have y minus 6 on this one. We got to get y by itself, so I'm adding 6 here because it's the opposite. Add 6 here. And we have our final answer of negative 1/2 plus 8, which hopefully you caught my error. I didn't put 1/2 here. That changes my signs. A lot of us made that mistake. Even I make that mistake, but we got to check our work, okay? All right, after today's lesson, you'll be able to verify triangle inequalities. Our expectations are the same as they were last time. You need to be watching this video and taking notes. All right, so our triangle inequality theorem states that the sum of the lengths of the two shorter sides must be greater than the longest side. So if side AB and BC are my shorter sides, this side and this side, regardless of what it looks like, if they're my shortest sides and length, if I add them together, they have to be greater than this third side. Okay, make sure you write this down. The sum of the lengths of the two shorter sides must be greater than the longest side. Let me show you what that actually looks like though, so it'll make more sense. So if we have a triangle and we're given these side lengths, we got 9, 3, and 11. We need to know, is this a triangle? Will it actually form a triangle? So we take the two smallest numbers, my 9 and 3, and I add them. That's it, simple addition. 9 plus 3 is 12. Is 12 greater than 11? Yes, it is. So we have a triangle. Okay, let me show you when we wouldn't have a triangle. Okay, so if instead we had AB equals 8, BC still equals 3, and AC still equals 11. Well, my two shortest sides, 8 plus 3, that actually equals 11. Since 11 is not greater than our 11, this is not a triangle. So if our two shortest sides add up to something smaller than that third number, we don't have a triangle. It adds up to, it's the same, so we don't have a triangle. What if AB was still 9, BC was 1, and AC was 11. This time, 9 plus 1 equals 10. 10, again, is not greater than 11, so we don't have a triangle. So if it equals that third number, it's not a triangle. If it's smaller than that third number, it's not a triangle. But if it's greater than that third number, it is a triangle. So let's look at another example. Determine if the third side is the longest side of the triangle. So again, taking our two shortest sides, simply adding them. That gives me 9. Is that greater than 9? No, it's not. So we don't have a triangle. So since 3 plus 6 equals 9, we don't have a triangle. Okay, the second half of our theorem is that the sum of the interior angles of a triangle is 180, and the sum of the exterior angles is 360. Be sure to write this down. Anytime that, as soon as you get to a page that says notes, please write it down and write down the examples as well. All right, in a triangle, the largest angle is across from the longest side. So let me show you what I actually mean by that. Okay, so in this triangle, let's first look at that first part that said that our triangle angles on the inside have to add up to 180. So right here we have two angles. We have a 92 and we have a 45. 92 plus 45 plus this third one over here that I don't know has to equal 180. So if I take the reverse of that, I take 180 minus our 92 minus the 45, whatever I get, which will end up being 43, is going to be this angle. Okay? So typically those are the kinds of problems you're going to see. You're going to be given a triangle with two angles, and you're going to need to figure out that third one. So we're just taking 180 minus the other two angles. All right, the second part of that said that the largest angle was across from the longest side. What that means is, what's our biggest number here? 92. That means that 92, this angle right here, is our largest angle because it's the biggest number, okay? The side that it looks at, this one right here, the side that is across, the side that it looks like at, is going to be our longest side. Okay, so that means that the other two side lengths have to be smaller than 11. So if 43, this one over here, this one is our smallest angle, that means that this side that it looks like at has to be the shortest side. Has to be. It has to be the smallest number here. Okay, so then 45, it looks at this side, so this one is going to be in the middle because 45 is in the middle of 43 and 92. It's not in the middle, but it's between those two. Okay. All right, so here's another example of something you might see. First, you want to determine what the third angle is. So again, all three angles have to add up to 180. So what did I say? I said we're going to take 180 minus the two that are given to solve for and find that third one. So we do that math, then that's 20. The second part of this is saying that the side lengths of our triangle, again, are 11, 9, and 3. But place them where they need to go. So if 115 is my largest angle, one is the largest, it's the biggest number. This side that it looks like, I'm going to pick out the biggest number. So that one has to be 11. Now let's look at the smallest angle so we can find the smallest side. So the smallest number here is my 20. So I draw my arrow to look at that side, find the smallest length down here, and that's got to be where my 3 is. So now I'm only left with the middle two, the middle angle and the middle number. So that means that this side that this one looks at must be our 9 centimeters. All right. There is a worksheet to complete on this. Let me know whenever you have questions over it. But make sure you have taken good detailed notes and ask the people around you for help.